Hello, ladies and gentlemen. So, what I want to do is I want to start off with talking to you a little bit about the primary trig ratios, the secondary trig ratios, and after that, I want to go into the sine law and cosine law. So, the trigonometry of right triangles is what I want to talk about right now, and that's talking about, first of all, a right triangle. So, you have a 90-degree angle and the side opposite the 90 degrees is called the hypotenuse. You're going to have an angle, and wherever that angle is, you're going to have an opposite side to that angle, and you notice that the opposite side is literally opposite in direction from the angle itself, and you're going to have a side that's called adjacent, and adjacent means beside, so it's right beside the angle, and opposite is directly opposite where the angle is, and then you have hypotenuse that is always opposite the longest side or opposite the 90 degree the hypotenuse is the longest side and it's opposite the 90-degree angle. You learned a memory aid, SOHCAHTOA, to help you with this. One thing I want to point out is that if I was working with a different angle, say I was working with phi, and yes, that's phi, and that is simply another Greek letter that we use to represent another angle measurement. In this case, that side would be opposite to phi, this side would be adjacent to phi, and this would still be the hypotenuse, because notice it's still opposite the 90-degree angle. The other thing you have to remember for the trigonometry of right triangles, of course, is Pythagorean theorem, and Pythagorean theorem says that the hypotenuse squared is equal to one of the sides squared plus the other side squared, and that is Pythagorean theorem. Now notice I write it a little bit differently than probably you've seen before. You guys probably know it as a squared plus equals, or a squared plus b squared equals c squared. The problem is, what if I goof it up and I happen to label C is one of the sides and not the hypotenuse. So I think it's important that you realize that it's the hypotenuse side squared equals side 1 squared plus sides 2 squared. Now, you are all very familiar with the three primary trig ratios. That's sine, which is opposite over hypotenuse, cosine, adjacent over hypotenuse, and tangent, which is opposite over adjacent. Well, there's also three secondary trig ratios. They're also called the reciprocal. Reciprocal. And remember what reciprocal means. It means 1 over. So this is the cosecant, which is the reciprocal of sine, which sine is opposite over hypotenuse. So when you invert that fraction and times it by 1, you're going to get hypotenuse over opposite. Then you're going to get secant, which is the reciprocal of cosine. So cosine is adjacent over hypotenuse. So when you invert and multiply that by 1, you're going to get hypotenuse over adjacent. And cotangent, which is the reciprocal of tan. Tan is opposite over adjacent. So when you invert that and multiply by 1, you get adjacent over opposite. And you need to know those. So that's new, and it's something that we need to know. So here's a very simple example. We're going to take a look at a triangle here. Notice I don't know my hypotenuse. So to find hypotenuse, I'm going to say that the hypotenuse squared is equal to 8 squared plus 13 squared. Using my calculator, 13 squared plus 8 squared equals, second function, square root. So my hypotenuse is simply going to be the positive 15.3 approximately. Okay, so that's what I have for my hypotenuse. That means that my three primary trig ratios will be sine theta. Now I got to choose where theta is. It says theta is going to be angle A. So here's theta. So that means that this will be opposite angle A, this will be adjacent angle A, and this will be the hypotenuse because it's opposite the 90-degree angle. So this will be my 15.3. So sine of theta, well, I guess in this case we could call it sine of A, is going to be opposite over hypotenuse. So it's going to be 8 over 15.3. Cosine of angle A, well, I just did that very wrong, didn't I? sine of angle A will be opposite over hypotenuse, so that's not going to be an 8 here. That's going to be a 13, so let's fix that up. This one's going to be cosine, which is adjacent over hypotenuse, so it's 8 over 15.3. And then you're going to get tangent of A, which is going to be opposite over adjacent, so that'll be 13 over 8. Now that's your 3 primary trig ratios. We can also come up with our 3 reciprocal trig ratios, or secondary trig ratios. And they are going to be cosecant of A. Now, from looking above, I know that it's going to be hypotenuse over opposite, or I can remember that it's the reciprocal of sine, which means it's simply going to be 15.3 over 13, the reciprocal of sine. And then it's going to have secant is next, so secant of A is the reciprocal of cosine, or hypotenuse over adjacent. And cotangent is going to be the reciprocal of tan, so it's going to be adjacent over opposite. And so here's your 3 primary trig ratios that you're used to. Here's your 3 secondary trig ratios or reciprocal trig ratios. These have a different graph than these do. We can talk about what the graph looks like, and you're responsible for knowing them. Okay, you can do a lot more work with them in grade 12. You're not going to do much work with them in grade 11 other than for me just to introduce them to you. You understand that they are the reciprocal of each other and maybe have a little idea what the graph is. However, I will not be testing you on the graph. Just get a basic idea of what it looks like, and you're going to do a lot more with that next year. Okay, that's it for this video, and then I want to come back talking about triangles that are not right triangles.